Yeah, let's go. All right. Thank you, everyone, for making it through the whole day. I know a lot of people are brain dead. I certainly am. It's been a heck of a day. Thank you, AV Squad. Thank you, volunteers and organizers. You've put on another great show. My name is Rich Dudley. We're going to talk about data lakehouses, kind of a nice heavy topic for the last session of the day. Like everyone who received a box, my assigned secret identity today was Tyler. Tyler, thank you for letting me borrow your name today if you're in this room, and I hope you had fun with your secret identity. At any time, feel free to ask me a question, but I have two very bright Klieg lights right in my eyes, burning my retinas. So if you're past the second row, you're really going to have to put a little effort into getting me to notice you. And anybody past like the fourth or fifth row, theater's full, theater's empty. I don't know. It's Voyager 1 territory to me. I cannot see it. So let's go here. Bill Inmon, the father of the data warehouse, has a lot to say about this new, kind of in the last couple of years, data lakehouse architecture. But the bottom line is, data lakehouses can simplify analytics, simplify governance, simplify quality, and they can really boost your BI and AI initiatives. We'll talk a little bit more about quality later on. Now, it is the last session of the day. They are 45 minutes. We have no Wi-Fi. We've got a long way to go and a short time to get there. So some of this stuff is going to be summarized. And if you understand both of the references on this slide, you are definitely my people. And bedtime is in about 4.5 hours for us. A brief timeline of some of the stuff we're going to talk about to set the stage for why lakehouse architecture was invented. We're going to start off by talking about SQL. I'm sure we've all worked with that. Some of us made a great living with that. We'll talk a little bit about NoSQL and what led us to data lakes and why we no longer really use data lakes a whole lot. SQL was great. It solved a lot of problems that we were having off of mainframes. I'm sorry I keep turning around. Let me stand over here so I don't keep doing that. SQL systems, on a positive, were very easy to administrate. They were all in one. You just installed a server on a box, and away it went, and it just ran. The storage was row-based, which was super easy because we understand those tables. That's how we work. It's part of the reason why Excel is so popular, because we get tables and columns. We can enforce the schema very strictly. If the data doesn't fit the schema, we then have a big long meeting, an architectural review, make some changes, and we can accommodate that, or we have to say, data, you don't belong here. Transactions were ACID transactions. And so data was very stable. It was protected. It was durable. That's a big positive when you're running a business. And SQL systems, for the most part, were very optimizable. On the downside, SQL systems tended to be all in one. You bought SQL Server from a vendor, and every piece that came with it is what you had. If you bought Oracle, you had all of the Oracle tool suite. Now, maybe you could plug on one or two things, but Oracle was Oracle, SQL was SQL. A lot of times you got into troubles with contention and locking under high load. We spent a lot of time optimizing databases, running no lock hints, and all that kind of stuff. Another big problem with SQL-based systems was all the data was in one file. And this led to some scaling issues. These systems were also very proprietary. So when you got into Oracle, you knew Oracle extremely well, and only some of that would transfer to other systems. And they tended to run on single servers or small clusters. Case examples of what I'm talking about with SQL Server, Oracle, SQLite, and of course the king of the category, Microsoft Access. Data warehouses were a common thing that were built on top of these SQL-based relational systems. And it was a structure that was absolutely ideal for doing business intelligence, reporting, dashboarding, stuff like that. How many sales did we have last week? How many sales did we have last month? What's our year-over-year to comparison? A lot of us in this room have made a lot of money doing that, and it was great. The data is highly governed with very predictable data structures, which was awesome because you weren't like getting all kinds of wonky stuff as long as you took care of business upstream. Now, the downside to data warehouses is the structures were very rigid. Again, if you needed to make a change, it took a long time to implement those changes. And of course, you've got all your people like, oh my gosh, the business is going to die if you can't get this done very quickly. And you're like, well, on purpose. We can't get this done very quickly because you wanted it very rigid, but that's okay. It was also very difficult to add history or modify the scheme, as we just said, and the scalability was always an issue. So back in the day, how did we scale? Well, we bought a bigger server, right? We had a small server. People say, oh, the reports are running slow, blah, blah, blah. What do? Well, we go and buy a bigger server. Two problems with a bigger server, and that is there is an upper limit to both servers and the amount of money your boss wanted to spend on servers. And usually the amount of money was the more limiting factor. This became a problem with a lot of systems. Just you couldn't go further. And then what? Well, some of the NoSQL solutions came out and said, okay, there's a couple of problems with SQL. First of all, not everything is tabular. So you can get the relations in a SQL-based database, but you can't really understand the hierarchy. Think about an org chart, right? You've got the bosses and the underlings, minions, GRU and the minions. And those don't always show up in a SQL tabular view. Yeah, granted, you can get the relations, but you don't have that full hierarchy. So NoSQL solutions, again, on the plus side, they tended to be all in one. They were not tabular, which was a definite bonus. They are highly governed, again, with predictable data structures, but only some of them, not all of them. And some can distribute the compute and storage. So this overcame some of those scalability issues that we were bumping into with SQL Server-based systems. You remember when some of these systems were first coming out in the early aughts? They're like, oh, we solve all these problems because you can like spread our data out all over a bunch of cheap servers. And then you have to go to your boss and say, okay, remember how we wanted to buy one big server? And they're like, yeah, we're not paying for that. And you're like, okay, now I need 6 small servers. Are you kidding me? What are you doing, right? Again, on the downside with NoSQL systems is there's varying support for schema enforcement. Some systems were really good at enforcing a schema, and some were not so good, especially when you got into key value stores, where the key was like, say, a company identifier. And then developers would do what? They would take this massive JSON object with maybe hundreds of data elements, shove it in there and go, hey, key value. And you're like, no, that's not what you're supposed to do there. They also, again, tended to be all in one, which meant that when you bought the thing, you had that thing. And if somebody else came out with some other feature that you didn't have, you're like, oh my gosh, like I hope you guys are working on it because everybody wants that shiny new thing. Again, they're still proprietary, which meant you relied on the vendor. These tended to run on small clusters, which, you know, if you're not getting one server, you maybe aren't getting 6. And the query languages tended to be very unfamiliar. SQL was nice. It was sort of straightforward. We all learned it. It's not so bad. But all of a sudden, things like if you've ever done Neo4j and sing Gremlin or Tinkerpop, like the first time you look at that, it's like E.E. Cummings poetry. And you're like, what is going on here? So NoSQL solutions got us a little bit further. We're getting a little bit more scalable. We're getting a little bit more flexible. But that wasn't enough. We still needed more. And that's where data lakes come into play. And this meme is not far from the truth. What ends up in a data lake? Typically piles and piles and piles of CSVs. And really, it's more like this. You have structured data, CSV, and structured, I think, here includes things like XML and JSON because they have sort of a regular schema. You have your full text data. This could be books. This could be help desks, annotations. This could be all kinds of stuff. And you have your what they call unstructured data. That's audio. That's video. That's things with no regular schema and just kind of sort of an endless length of bytes until it actually ends. You put all of those into a data lake, and then oh, the arrows aren't showing up. That's kind of cool. The arrows are really light. There's supposed to be arrows between those things. As if by magic, between the open data lake, it enables machine learning. And if you remember, like in the early teens, like what was going to save the world? Machine learning was going to save the world. Everybody become an ML practitioner. And what happened? Well, what happened is, well, we're here today, so you can review that history. Data lakes kind of solved a few of the problems we were having with SQL and NoSQL solutions. They handled volume of data, they handled velocity, they handled a variety of data, and they handled variability in the schema, kind of. They certainly handled scalability, especially when it came to storage. You can definitely swap the parts of a data lake architecture. It's very swappable. The standards were open. They're either under like Linux Foundation or Apache or one of the other open standards foundations. Allowed for massively parallel execution, which was essential. Because one thing that's not in a data lake is any sort of indexing. So anytime you would run a query, it would go through that entire mess of stuff. And if your results were 1 record or 20 million records, your query would take 20 minutes either way. And that was a real downside when you compare it to SQL solutions who scaled linearly. If you had a short data set, it came back quickly. If you had a large data set, right, it took a little bit longer. That was a sign that you were getting too much data in there. In this case, because it was unstructured, they would do the parallel execution, and that was kind of their way of speeding things up. However, this is the structure that enabled data science and machine learning, because both of those require a massive amount of data, and you just need to get in there and kind of mess with it and ask questions and play with it, so your schemas are irregular. Maybe they can't be so enforced. All of that was done in your query software, which was either like R or Python or whatever thing you were working with. Some of the stuff that data lakes failed on, though, was versioning. If you've worked with APIs for a number of years, you know that one of the big headaches is how do you ship a new version of an API? Where do you put the version indicator? Sometimes you put it in the URL, sometimes you put it in the content type, whatever. Versioning is always a problem when you add data to a system. And it's even worse when you take data out. Schema enforcement. There's absolutely no schema enforcement in data lakes, which means anybody could put anything anywhere in your data lake. And this kind of tended to become more of a data swamp, is where people would refer to things. So you could end up with this, think of an S3 bucket or whatever, just full of whatever files. And you're like, oh my gosh, this is like not even the right stuff in this part of my data lake. There was no concept of data quality in a data lake. Again, getting back to the data swamp concept there. There was no consistent integration, no consistent stack of technology. Another big problem with data lakes that they failed on is guaranteed reads. And this is a really bad thing if you're trying to do analytics, because at some point in time, your data lake would just be like, I don't want to read that file. And there goes the year 2013's data. It just doesn't show up. Why not? Because it didn't feel like reading it today. Not good for an analytics perspective, which meant they were terrible for BI use. And machine learning was kind of cool, but it's very expensive, and BI is what was really driving businesses at the time. They also failed at simple and familiar queries. Like if you thought the query syntax on NoSQL was a nightmare, try working from a data lake. And they also ended up building silos, because siloing your data was really the only way to keep people from putting the wrong stuff in your buckets. One of the main technologies that enabled data lakes was Hadoop. And the Hadoop ecosystem, if you ever looked at it, was extremely fragmented. And this meme explains exactly why. Why is the Hadoop ecosystem fragmented? Because the guys who developed this thing didn't like that thing, even though conceptually they're damn near identical. That's just how it went. As an example of this, the file system was Hadoop, HDFS. That was pretty consistent through the whole deal. Your storage engine could be anything like HBase, Ozone, Phoenix, Hypertable, which is now BigQuery in Google. Why? Because the Hypertable people didn't like HBase, so they flipped the table over and milked a different almond. Scheduling, Yarn, Airflow, there's a whole bunch of other ones out there. These are the two that kind of still stick around. Your query languages. Pig, Hive, Mahout, that's just like the query languages. And then you could use your programming languages, R, Scala, Python. And processing. Your processing engines, MapReduce and Spark were the big ones. There's a few others that never really got traction, and there's a couple dead projects out there now. As I mentioned before, something missing from your data lake architecture, indexing, data governance, and data quality. And all of these cause them to really build out this data swamp type of concept. So we ended up a few years ago, actually I think last year, with AI really emerging as like, oh my gosh, like forget what we thought about BI, changing the business. Forget about what we thought about machine learning, revolutionizing our business. AI is going to revolutionize our business. But what's the problem? Well, none of the previous solutions really unified our data into one area to where it's easy to work with, it's well governed, it's highly structured, it's predictable in a way that is required for AI. And that's where we get into, behold, the data lakehouse. And you can tell that I took this from a thing that was published last year because they don't have AI up here. I just noticed that this morning when I was going through the slides. Like, it's not there, and it's half the point of these things existing. So we started with data warehouses. Very predictable structure. They did BI and reporting extremely well. We took data out of our structured systems. Could have been an ERP system, warehouse management, whatever you're running at the time. Run it through some ETL into your data warehouse, out to reports. Killer. And that still operates today. I don't want to say this is not a great paradigm. It's still an awesome paradigm, and it shows up down here. The data lake, you would get all of your stuff. You'd combine it. If you wanted a data warehouse, you had to run some ETL and MapReduce, make yourself a proper data warehouse to do your BI and reporting, which is really funny because one of the inputs to a lot of data lakes was, in fact, itself a data warehouse. You would take stuff out of a data warehouse and you would remash it, and then you'd put it back out the other end into a data warehouse. Very confusing. So we end up in a data lakehouse. And the beauty of these things, I'm absolutely going to fall, and if I fall, I want somebody to take a picture and send it to me. Data lakehouse supports all these different workloads. It supports BI, supports reporting, supports data science, supports machine learning, and not shown on here, it supports AI. And the reason that this works is because of this magical layer right here, the metadata and governance layer, which sits on top of a data lake type storage. So we just talked about data lakes and how they're swamps. It's okay, hang on, we'll get to that. But the metadata and governance layer is really the thing that makes that work. All right, so characteristics of a data lakehouse. How are we doing? Oh, we're rocking. We got half an hour. Data lakehouse characteristics. What really are these things? Well, the first characteristic of a data lakehouse is all of your data is in one place, from the raw data to the referential data to your master data to your dimensional data. Now, that doesn't mean that your lakehouse is the back end for everything. That means that you can ingest it from all of your sources and put it in one spot to work with. Again, supports BI, ML, and AI, which means it has the scalability, it has the query flexibility for those types of things, it has the data exploration capabilities, and it has the consistency that's required of data for BI. Lineage, metadata, and security governance. This is the first time we've really talked about these. We'll go into a little bit more about this. Lineage allows you to trace from start to finish where data came from. And that metadata and governance layer that I showed you just a little bit ago is one of the things that does that for you. The standards are primarily open. So when you see lakehouses, it could be Databricks, it could be Microsoft Fabric, it could be whatever crazy thing AWS is trying to cook up this month and say this is the greatest thing ever. It's usually built on open technologies. I'll get into a little bit of that in future slides. It's slightly opinionated in the technology stacks. When I talked about the data lake, I said, oh yeah, you can pick and choose all your stuff. And so one of the things as an architect, I would sit there and look at that and go, what the heck are we going to build this thing with? I built a number of data lakes. I worked for a large company, and we had some subsidiaries, and each subsidiary had their own thing. So we'd sit there and go, okay, what are we going to do with this thing? We'd have to figure it out. Vendors have kind of gotten slightly opinionated in their technology stack, and that's not a bad thing. That doesn't mean it's a proprietary stack per se. There's still some swappability in there, but they're like, this is really the smoothest way to work you all through there. Well, I'll talk about that in just a minute. Whoops. Some parts are swappable, and there's a rich partner ecosystem. There's a lot of encouragement that instead of being just one proprietary thing, it's like, hey, a lot of people, because these standards are open, can develop stuff on top of this and be part of our lakehouse platform. I need a sip of Diet Coke here, sorry. All right. At the top level, in a lakehouse, you have what's called a data catalog or a meta model. And this is an abstracted concept. This is enforced by the software that you are using. It could be Unity Catalog if you're Databricks. It will be Purview in Microsoft Fabric, at least that's what they're saying now. If you're in AWS, you'll use some combination of Glue and Hive. The meta model is the thing that keeps the metadata, the data models, keeps all your transformation rules, or at least most of them. It handles your lineage, and it handles the security to the data. That was something also that was missing in data lakes, is managing the security. So the meta model is extremely important, and it sits at the top, or in the picture of, a little bit ago, it was the thing in the middle that I pointed out as being super important. Below that are a couple layers of stuff, and layers in data lakehouses is an overloaded term. There's really two that we'll talk about. One is the data layers, also called the medallion layers, because they're rated as bronze, silver, and gold. And if you've ever watched the Olympics or some other competition, what do you win? You win bronze, silver, or gold medals. So it's called the medallion architecture. There are also technology layers, and these are broken up, again, into 3 different parts. There's the storage layer, there's your compute layer, and there's your consumption layer. So we're going to try and keep going on some of this stuff. The medallion architecture. This is similar to raw, refined, and published way back long ago in the data warehouse days. But the main difference is the amount of stuff that you can put in there. So the bronze layer in your lakehouse is the most raw stuff. Get an API request, just drop that JSON or XML right there in your storage. If you're importing CSVs, just drop them right there. Do nothing with it. Stick it there. That is your raw layer. That goes into the bronze layer. You will then run a series of transformation scripts to transform whatever you just got into a table structure using a more native table file format. I'll talk about those in just a second. The reason you do that is with lakehouses, like I said, they're not, or excuse me, with data lakes, they are not indexed. And querying directly against files is inefficient. So you take that highly variable raw data, stick it in a table. Now it's indexed, and now it's more performant. You could, if you still wanted to, work directly against your source files. I don't recommend doing that. You're going to be there for a while. Your silver layer, that is your standardized data. This may not make a whole lot of sense if all you have is an ERP system, because the ERP system enforces all of your data. But if you work in a highly variable data environment, this is your standardized data. One of the examples that we have, so the example that I have, we support analytics for a number of different small business systems. And we extract data from QuickBooks Online, we extract data from Sage, we extract data from FreshBooks. They all have invoices, but the invoices have a different schema. So we've got our QBO landing, we've got our FreshBooks, we've got our Xero. Good job. When we get to Silver, we have come up with a unified model of what an invoice is for our needs. Does it include all of the data from everything? Yeah, not really. Only the useful stuff. And ideally, you strip out the things that you really don't want to be in there. The gold layer then becomes the most highly refined data. That's your AI. That's where your AI and BI is done. That is really your data warehouse layer. Facts, dimensions, references. Sometimes it's just a straight copy from Silver, but it's really your conformed facts and dimensions. Sometimes you will have a landing layer as well. Sorry about that. This is a killer allergy season for me, so I'm giving it my all, and I'm going to try not to sneeze horribly into this microphone. Sometimes you'll have a landing layer as well, and this is if you have external partners who are pushing data to you. You want to set up sort of a little bastion zone of containers where that provider can push you the data. You are then going to grab those data files, move them inside to your VNets or in your more protected location, so there's nothing sitting out there in your unprotected space, in your publicly available space. You don't really need a landing layer if you're not having external partners providing you with data. So one of the questions I get a lot is, how does Bronze line up with S3 or Azure Data Lake Storage? And it kind of looks like this. And I used buckets because the Microsoft glyph for Azure Data Lake Storage is a folder, which drives me bananas because it's not a folder, it's blob storage. Whatever. I don't draw those. So anyhow, the nice thing about Microsoft Azure is it has this concept of a storage account. And you can make different containers in the storage account. So when I lay out a lakehouse in Azure, I have a Bronze storage account, and I put all of my Bronze containers in there. And you can see I have a, well, all right, that's kind of crappy to read. Unfortunately, I don't have a giant movie screen at home to test the slides on. So you got what I could put on just like a large 4K monitor. And this is a little bit light. Sorry about that. I'll put these online. You have landing and you have your loaded or your transformed in your bronze layer. No changes to the data, just the most raw stuff and the most raw stuff in a tabular format. In the silver layer, I tend to put a container for the different entities. So I'll have like invoices or I'll have like ledger data with your different conformed entities there. And in the gold layer, I'll have different buckets for the domain metrics or whatever we're doing there. And all of these are ensconced in those nice storage accounts. And same thing for the external landing. I may have several different external landing storage accounts just based on how many partners are pushing us data. The thing I really love about Azure is you can put the networking restrictions, the subnet trusts, the IAM controls, the ACLs, all of that at the storage account layer. And it's great. AWS doesn't have the concept of a storage account, so you sort of have to like virtually group your buckets and just keep track of which one's bronze. And then you apply the, you can apply your IAM controls directly to the buckets from a template. Sorry. All right, medallion security. Data security is a huge thing, obviously. So we're going to talk about this just a little bit. For your medallion layers, you only want to access the data through your platform's UI. You do not want to access through, that mess it up? No, okay, good. You don't want to access your files directly. And as such, you will put your security in that meta model or in the catalog. In the bronze layer, it's likely full of PII, PyPhi, all kinds of stuff that like your risk team is very worried about you having. So it has the most restrictive access. Really, your data engineers are the only one who need any access to that, and that's just because you have to write the stuff that moves the data out of the bronze and into the silver. With the silver, you want to try and anonymize the data as much as possible, which means you can loosen up on the restrictions just a little bit. This is where your data engineers work. Your data scientists will work here in your silver layer. And sometimes your data analysts. The data analysts are the ones who are primarily responsible for like Power BI reports and stuff like that. And again, no access to anyone outside of your organization. Gold, primarily anonymized, facts and dimensions, which means that this is the least restrictive type of data usually. Data engineers, data scientists, data analysts, you can have your business users, you can put your AI on here, and you don't have to worry too much about like something really critical getting out into someone's hands who shouldn't have it. With the landing, if you have a landing layer, there's limited access outside of your organization, and the data here is restricted again to your data engineers only. So in my mind, this is like probably one of the most important slides that I have here, because I get asked this 1,000 times a week by my InfoSec team, like, how are you securing this? I'm like, I just sent this to your boss. Well, he didn't tell me, so yes, okay, here you go. So, excuse me again, that was the medallion, and that's pretty much all that we did, but you saw how I laid out the bronze, silver, and gold into the containers and the buckets. So that was your storage layer also. They line up very closely. Medallion is in your storage layer. It's almost always blob storage. So if you're on AWS, you'll use S3. If you're in Azure, it'll be Azure Data Lake Storage Generation 2, because S3 was taken. And if you're in GCP, it's object storage. We really got to work with Microsoft on the names. You will have a lot of buckets or containers, a lot. And everybody will look at you and go, why do you have so many buckets and containers? You're like, guys, it just makes sense. It's nice this way, just leave it. The data formats, again, for your raw and your landed in your raw bronze, you'll be CSV, JSON, XML. We talked about those just a minute ago, all the raw stuff. Your transformed bronze, that's the tables. Your silver and gold will use a data file. And again, this is where we're getting into swappable parts, right? Maybe Delta Lake, maybe Parquet, could be Avro, Iceberg, Hoodie, and there's a few others that are out there. But I'm going to call out Delta Lake and Iceberg for a couple of really important reasons. Delta Lake is Parquet on acid. So Parquet, Avro, and Hoodie, maybe Hoodie does now, but Parquet and Avro aren't acid compliant. And so when you start using them in systems, like a lot of the database people are like, hold on, wait, what do you mean? Like there's no. So Iceberg and Delta Lake added transactions and acid compliance to these open source file formats, which is great. And there's history, time travel, and versioning in these. There's partitioning, indexing, all kinds of stuff to make these things really work. So you'll see these terms come up, and if you have a preference for file format, Delta Lake and Iceberg are the two that are gaining the most momentum right now, and they're both really, really good. So, you know, just because they're weird, don't overlook them too much. Contrast that with back in the SQL Server days, you had an MSDB file. What was the format? I don't know. It's whatever Microsoft wrote it as. Is it compatible with anything else? Nope. Why? Because it's proprietary. Here, if you build a whole lakehouse on top of one system, you're like, God, you know what? We don't want to do business with these guys anymore. How do we change things? Well, the good news is that Microsoft Fabric, Databricks, all these other systems, they all read Delta Lake. So you're like, yeah, well, let's just fire up a thing and let's see if we can just read these files. Chances are you can. And you'll just have to do a little bit of rework in your notebooks. So the movement, if you have to, is minimized. So real quick storage layer comparison, because we're about 2/3 of the way through. We started out with data warehouse. For whatever reason, these are out of order. I don't like it, but whatever. Data warehouse is closed proprietary. Data lakes are open format. The more preferable form shows up in the lakehouse. Open formats. Data lakes, like we said, low quality data swamp. Data warehouse, high quality. What do we want? High quality. It's in the lakehouse. We get really fine-grained access control in lakehouses, even down to the row or column, which is really cool because like you can mask certain columns for certain people, and the risk people like, oh my God, you could data mask. This is wonderful. Yeah, totally. It's really cool. Storage layer security. Only landing should have direct public access. Your highest restrictive access is data engineers only, and you should have multi-availability zone replication at a minimum. Don't build your lakehouse in just one availability zone. You want to spread your data around for all the reasons that you spread data around. It's tough to go multi-region because it's really easy to get your data files to go multi-region in like your blob storage. It's extremely difficult to actually get all the other stuff that has to run your lakehouse in multi-region. So think twice before you're like, oh, let's go multi-region. Not always easy. Some upskills like I promised you, if you are a SQL person or just someone looking to extend your career, basic security, medallion architecture, being able to explain a medallion architecture fluently, differences between the file types, especially Avro and Parquet, and what makes Delta Lake and Iceberg so nice. How do column stores work? This is like classic interview question. How does a column store work? No one interview me right now. I'm on a roll. Advanced stuff, partitioning strategies, time travel, and data retention. That was a lot for storage. That is just like, we've just stored data. We haven't even started working with it yet until this slide. So now we're working with our data, and we have to compute. So somebody wants to run a query. This happens in your compute layer. Almost always, the compute layer is Apache Spark when you peel back the cover. So if you're working with Microsoft Fabric, they have all these fancy names for like these fabric compute nodes, blah, 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 blah. It's Spark. Yep. Back in the day, there was Trino, Flink, Presto, Hive, Impala, Amazon Athena. Why do all of those exist? Because they didn't like those animals, so they milked an almond. Compute is elastic and it scales to 0, which is good and bad. It's good because it's like cheap. Well, boss, if I go to lunch and forget to turn it off, after 10 minutes it turns off. The bad news is that when somebody fires off an API request, you got to kick the machine to wake it up. And that can take anywhere from, I'm not making this up, 10 seconds to 5 minutes to wake up your nodes, depending on what you're using. Most APIs time out after 30 seconds, so make it quick, my friends. Spark is great because it's compatible with almost all the open source storage formats. To program Spark, you'll use Python, you'll use Scala, you can use R, you can use Java, you can even use SQL. I don't think anybody has gotten .NET into a notebook. I could be wrong because I don't really watch that space a whole lot anymore. So the big things, if you're looking to like extend your career on the compute layer, know about Python, know about PySpark. Something you're going to use a heck of a lot of, Spark data frames. And your advanced stuff, Spark execution plans, of course, performance tuning is always a thing. So we've stored the data. We've started to compute this. Oh, you will work with, what's your programming environment for this stuff? It depends on which system you're using. So I work mainly in Databricks. They have a really cool like web UI that's really good. They also have a plugin for VS Code, which we use a lot of as well. And so that's kind of cool. So we can work in a local IDE. There's also a plugin for data grip from JetBrains. So you kind of get your choice of what IDE you want to work with. And then we get our, what, 10 minutes already? Holy crowley. All right. So sorry about that. So it will depend on that. That's why I don't have screenshots of this. Plus, we've got 10 minutes. Like I said, we got a long way to go in a short time to get there. All right, let's get through here. How do we consume the data? Great, so we've stored it, we've computed it, we've calculated our whole gold layer. How do we share our magnificent data with the rest of the company? Well, there's a whole lot going on in this space, and it's changing rapidly. So one of the most common ones, and sort of the tried and true, ODBC, JDBC connectors. You can build services on top of that. Some of the new cool stuff is called these genies, which is text to SQL, natural language processing, where someone can literally open up their UI and say, hey, what were our sales last month? A small LLM interprets that natural language query, reads the meta model, executes the SQL, brings the data back. Let me show you. You show that to your business users, are like, oh my God, give them a really big server. Delta sharing is another way. This is primarily a Databricks thing, but it's just an open sharing protocol that allows you to hook up things like Tableau, Power BI, and whatever directly to your tables where you give it permission. Two new things that have come out because what this world lacked was enough API schema protocols. MCP and agent-to-agent are new because we just didn't have enough API protocols. They have the promise of making things more interoperable, which sounds like every previous API schema that I've worked with over the last 25 years. Upskilling. Know about Delta sharing, know about MCP, understand the options that your chosen vendor has. Finally, let's talk a little bit about data quality. Data quality has always been an issue. Back in the machine learning days, if you had bad data, what did you get out? Steaming pile of poop. When you add artificial intelligence on there, you get a sparkly steaming pile of poop, right? With generative AI, you get rainbow sparkling pile of poop if your data is bad. And your agentic AI, if your data is bad, you just get a lot of small piles of poop. There is a lot to work with data quality. It is a science unto itself. So when you are developing in your lake houses, be familiar with common data quality issues. Explore your data. Delight in the joy of the poop that you find. We have regular meetings with the bad data that we find, and we laugh ourselves silly at just how bad some of the data is. There's a technology called data expectations, and they're really cool. They're like unit tests on top of data, and they can run live in your tables for data quality monitoring. Definitely keep an eye on those. That's an emerging space. But these things just like data expectations, it's a technology that just plugs into on top of your files, whether it's Delta Lake or Iceberg, so it becomes a native part of your Lakehouse platform. All right, governance. I'm getting there. So governance, there's two types of governance. There is security governance and there's metadata governance. This is a key feature of a data lakehouse. So although your storage and compute are distributed, they're all treated as a single silo by the unified governance layer, right? That data catalog, that meta model. Your access rules are enforced through the UI. So the security governance is enforced through the UI. And that ties into whatever you're using for authentication in your company. For us, it's Entra ID. It's probably the same for a lot of people. Could be Auth0, could be whatever. Metadata governance is enforcing the different schemas. It's kind of been a part of things for a long time. If you say this is a number, you can't shove a large string into that column. That is important because as your volume of data grows and your variety of data grows, and maybe you're getting stuff from different vendors that columns have the same names, you start to have collisions between data types, and it's no one's fault, it's just life. How do we deal with that? Well, you work on that with your import scripts, but that is caught and enforced by your meta model. All right, cool beans. We're getting close to the end here. 5 steps to building a successful data lakehouse. Start with a data lake kind of concept. Like, we need to bring all of our data together. That's the concept you start with. Don't actually build a data swamp. Plan it out really well. Bring quality and governance to your data lake from the start. Like, it's too late at the end. Optimize your data for fast queries, provide native support for machine learning, and prevent lock-in by using open formats and APIs. That should be standard and out of the box. This comes from a document called Building the Data Lakehouse. That was written by Bill Inmon. I don't know where the heck it went. It was online until like 2 days ago, and now I don't know. It's just like they pulled it for whatever reason. It was published by Databricks. I'll see if I can find a copy and make it available. So having built several data lakehouses and a whole bunch of data lakes, I have some additional suggestions. Lakehouses are complicated with a lot of moving parts. First, make it work, then make it work better. Don't let perfect be the enemy of good. You definitely wanted to like build this out, iterate on it, let people work with it, let people celebrate what you've done. All right, there's a couple platforms that you're going to find out. Databricks runs on all the platforms, AWS, Azure, GCP, and as of like earlier this week, SAP. Snowflake is a big one you've probably heard of. They have great booths at the big shows. They've got like a big F1 race car. Microsoft Fabric, Cloudera, who used to be a Hadoop vendor, is now rebranding as a lakehouse. Dremio, AWS, if you're on AWS, it's kind of like Legos. You've got to build your own. Every vendor on the planet will tell you that their product solves all of your problems. Yeah, sure. We'll go with that. So you have to know enough, all those upskills and stuff, you have to know enough to sort out vendor BS. When you're looking ahead to architecting these things, upskills, the well-architected framework, most companies have them. Be familiar with them because you're going to get pressed a lot. The lakehouse paradigm is absolutely mind-boggling to a lot of people. And like you have your warehouse people going, well, why don't we just use a warehouse? And you have like your security team going, this is a freaking nightmare. You have to be able to answer all of those questions. And like the CTO is like, okay, how much are you spending? All of those things are covered in a well-architected framework. So track those down. Cost management is always a thing. Great, last couple of slides. Lakehouses. Is there any place where a lakehouse is a bad idea? Yes. Don't use a lakehouse as an operational backend. Like I said, compute often scales to 0. It's not very good. Foreign keys don't actually exist in data lakehouse formats. And that's like one of these things that when you tell it to SQL people, like it's either mind blown or they're like, forget it. I'm out of here. This thing's crap. We're not using it. So, don't use it as an operational backend where you need highly enforced foreign keys. Also, the normalized relational database with key enforcement. So I've got these lights right in my eyes. Couple of references. They're not going to mean a thing to you because nobody can click on them here, but they're there and I'll have them online. Watch the Discord. I will put the slides up online and I will post that link in the Discord. And with that, thank you everyone for making it. I hope you all had an awesome day. I can see nothing in this room right now, so if anybody has any questions for the next 3 minutes, I don't know if we can bring the house lights up or if somebody just wants to like jump up and wave their hands, and I'll take the questions as best I can. So anyhow, thank you very much. Woo. Yeah, that was all running on Linux in LibreOffice, so if you ever want to know, like if Copilot on your Windows machine really annoys you, you can switch to Linux and do good stuff. All right, yeah, I see a question over here now. Is there an open source solution for Lakehouse? Yes, although not as a fully unified platform. So you'll end up piecing stuff together kind of AWS style, usually built on like Delta Lake with your file formats. There's an open source Unity catalog as well. Your storage or whatever, you're going to rely on whatever hardware that you have. For reporting in BI, you can do a lot with scikit and other Python things in your notebooks. So yes, you can absolutely piece one together, and that's actually an excellent question. Like with so much of this being open source and with so much of this being open standards, why would you buy a platform rather than just building one yourself? It all comes down to whose engineers do you want to pay. Do you want to put a team together at your company to like manage all of the compute nodes and everything like that, or do you want to pay somebody else? So yes, all of the stuff that I talked about has open source analogs. Obviously, like the Unity catalog from Databricks, they open sourced it. But like there's some Databricks specific stuff that they charge you for that's not in the open source part, that's specific to their platform. But yeah, you can absolutely piece something together completely with open source. Yeah, thank you. Great question. All right. I saw another hand. Let's see. Hold on here. Yes, I think. Okay, there's two of you. Okay, yes, sir, you first. I think, sir. Yeah, sorry. Okay, so how realistic is having a not operational backend because it's a practical challenge? So you would use other systems for your, your real-time types of backends, and you would extract the data into your lakehouse for analysis. A lakehouse is primarily an analytics type system, unless you really finely tune it. One of the challenges with AI is people want to I want to make decisions on this loan, or I want to make decisions on this thing based on an AI function that you may have built out. And we need to do that in real time. That is a real challenge because just like AI in itself is not really fast. So a lakehouse itself is not suitable for being a real back end, but you would use your traditional stuff for a back end and then slurp your data into the lakehouse if that makes sense. Oh, thank you. Yes, and I think, what is it, 1 chair over, 2 chairs over? Yeah, there we go.
Do you have any suggestions on the governance side of things? Because I know that that's one thing that's a lot of, because obviously it's a lot of documentation. There's no way to actually make it happen. It's hard to get some buy-in.
Oh, buddy, yeah. So do we have any suggestions on governance? Yeah, and actually, there is a whole body of work. The Data Management Association, right? Are you familiar with DAMA and the DIMBOK, the body of knowledge? It's a whole practice unto itself. And that's DMBOK. It's the DAMA is the Data Management Association, I think is what it is. So that is a whole science behind data governance, how to set up and run effective data governance organizations. All of those concepts translate well into a lakehouse-style architecture, but you're right. It is extremely hard to get people to buy into governance. And one of the most effective strategies I've had is just reporting on the crap, showing them the sparkly pile of poop that comes out, and then walk it back up the stack. What's missing in a lot of places that I've worked, even the one that now, is no one really walks it back up the stack. And we had an incident, not an incident, but an example the other week where in the phone number column, we had values that said United States. Why do we have the value United States showing up in my phone number column? We walked that back up and found out where people were doing that and said, don't do this anymore. This is what's happening downstream. And showing that to leadership also, kind of helps point out that, listen, you guys really aren't doing a great job here. And one of the reasons why, if your sales organization or your marketing organization doesn't have great data or doesn't have effective analytics is because we're not governing this well. So really, sunlight is the best disinfectant, they say, right? Let's bring these things to light. Let's show you what it is. And regular meetings help a lot of the time. All right, cool. I think we're running low on time. Are there any other questions? So I absolutely cannot see with these lights. If not, come on down. We could talk it through, or I'll be in the hallway, but let's grab some popcorn too. And I have no idea who any of those Avengers characters are. I am so out of the Avengers loop. I have no idea. So this will be exciting for me just learning who these people are.
You want the list?
Is there a list? Oh my gosh. You are a governance organization of your own. All right, thank you all very much. I hope everybody had a great conference.